drove from Jerusalem down to the lowest place on earth, the Dead Sea, descending at a rate of 12 meters per minute. He was at the sea level after 30 minutes of driving. Graph the relationship between a mirror's altitude relative to sea level and in time. All right, so let's break things down. Let's kind of do a quick review. Remember, when you're graphing an equation, you always have something normally that looks like this. Y equals mx plus b. And what I really want to concentrate on right now is what m is. M always means either the slope or, as you may remember from 7th grade, R rate. So that slope and is the same way of saying rate. Well, this is really nice to know because if we look at a word problem, it actually tells us what our slope is by reading right here. It says that it's descending at a rate of 12 meters per minute. Well, this is really important here. So we can actually say that our slope for this thing happens to be 12 per minute. So 12 meters per 1 minute. But remember, it did say the word descending. So it actually gives us a negative slope. All right, so that's the first thing that we can realize. Now, another interesting piece happens to be this statement right here. He was at the sea level after 30 minutes of driving. Well, that may not make sense right now, but it will be very beneficial to us when we look at the graph that's down below. So down on the graph below, if you look, this place right here says that the y-axis represents altitude and the x-axis represents time. Now, using that last sentence, we can actually plot a point. It says he was at sea level after 30 minutes of driving. So sea level, if we were looking at altitude, happens to be at 0 meters. And he got to 0 meters after driving 30 minutes. So if we use that, we can actually create an ordered pair by saying my x is 30 because x represents time and my y is 0. So we actually just found out by reading that last sentence the x-intercept. Okay? So I draw a point. Now, my job is to go ahead and try to graph this. So I know I have a point here. Well, I could do it a couple of different ways. One, I can, well, actually, let's do it mathematically, all right? So let's do this. We'll clear off our screen. We're going to clear off our screen, and what we're going to do is we're going to use that equation again, y equals mx plus b. And we're going to plug in the things we know. We know for a fact that our slope happens to be negative 12. So I'm going to plug that in the place of my m. We also know what our x, we also know a point. We know that we have 30 and we have 0 for our x and y values. So let's plug those into our calculations. But what we don't know right now is what our actual y-intercept is. So we can actually calculate that by doing this. We take negative 12 and we multiply that by 30, and you get that 0 is equal to negative 360 plus b. All right? And now we're solving for b, so we add add 360 to both sides. And I get that 360 is equal to b. What I found just then is my y-intercept of my equation. So I can actually say that my next point would be right there. And now that I have both of those points, I can simply connect my dots to the best of my ability. Sorry, that was not perfect. And we know just by that information that our equation for that line we drew is y equals negative 12, which was my slope, times x plus 360, which was my y-intercept. That's how we could have done that algebraically. Once we knew a slope and we knew a point, we plug it into our equation. And that's really what's happening here. In this particular problem, you're giving the slope and you're given a point. Your job is to find the equation. Another way that you could have done it is by using this value that we talked about here. Let's see. By using this point right here, we could have gone down 12 and then gone over 1, gone down 12, gone over 1, so forth, and just kind of kept that slope. And then I would have had that same line that was drawn as I was using the slope to do it. But the easiest way is to do it algebraically. Know your slope, know your point, and then plug it in, and then solve for your y-intercept. Hopefully this helps you out.